Alright, let's sketch the following function with attention to domain range, asymptotes, intercepts, and end behavior. So here's our function. This is a reciprocal, it's a linear reciprocal function. F of x is equal to -2 over 2x minus 8 plus 3. What you can do here is you can simplify it. You can write this as f of x is equal to -2 over 2. I'm going to factor out the 2 on the denominator. You get x minus 4 plus 3. And what you could do here is you can cancel out the 2. So technically you can rewrite this as -1 over x minus 4 plus 3. I'll give you the same answer if you work with this function or this simplified function. Let's work with the simplified function. Now just by looking at the simplified function, you can notice that the domain of this function, x can belong to a set of all real numbers, but one value that x cannot take on is 4, because if x is equal to 4, then the denominator here would become 0, and that becomes a restriction. So x cannot equal 4. If you look at the range here, right, y can belong to the set of all real numbers, but the one value that y can't take on, and if you take a look at your function here, this portion here, the -1 over x minus 4, there's no value of x that can make this 0, right? The only way you can make a fraction 0 is if the numerator is 0. In this case, the numerator can never be 0, so as a result, 0 plus 3 doesn't happen. Y belongs to the set of all real numbers, but y cannot equal 3. So that's something that you want to note. Then the next thing you want to do here is look at asymptotes. Now, we said that the vertical asymptote is the restriction on the domain. We can see that x cannot equal 4. So the vertical asymptote is basically going to occur when x is equal to 4. That means that this point will not exist on the graph, so the graph will not cross x is equal to 4. The horizontal asymptote occurs as a restriction on the range. In this case, the horizontal asymptote is y is equal to 3, and we know that the graph will never cross y when it's equal to 3. Okay, so these are two values that won't exist, and we can use this to kind of sketch our graph out, right? So if I do kind of create a generalized sketch here, and I'm going to make each unit go up by 2. So I'm just going to draw out a grid here. Okay, so I'm just going to go up by 2's. This is like 2, 4, 6, right? This is 0, -2, -4, -6, right? You can kind of create an appropriate scale for your graphs. Okay, so that's my sketched Cartesian plane, and what you want to do here is let's plot our asymptotes. My vertical asymptote I'm going to do in red. So this is my vertical asymptote. Okay, so this is my vertical asymptote. X is equal to 4. My horizontal asymptote is y is equal to 3. I'm going to just do this in blue. So y is equal to 3. Let's say it's the midpoint of 2 and 4. Okay. Technically you would want to use a ruler for this. So y is equal to 3, right? Just getting an idea of this. Let's take a look at some of our intercepts. So to find our intercepts, what we have to do here is we need to find our x-intercept. I'm going to let y equal 0, right? So I'm going to let f of x equal 0, and if I let f of x equal 0, you get -1 over x minus 4 plus 3 is equal to 0. I'm going to move the 3 to the other side. You get -1 over x minus 4 is equal to -3. What I'm going to do here is I'm going to do the reciprocal, right? So you get, and the negatives can cancel out if you divide them, right? So you get x minus 4 is equal to 1 over 3, x is equal to 1 over 3 plus 4, and you can imagine here that 4 you can write as 12 over 3. So this is basically 13 over 3, so it's slightly higher than 4, so the x-intercept here is going to be like 4.33. And this keeps going, right? So this is like 4.33. So 13 over 3 is going to be like somewhere here. So this is 13 over 3 and 0. So that's my x-intercept. And then you also want to figure out your y-intercept. Well, if I'm figuring out my y-intercept, I'm just going to let x equal 0, because at the y-axis, x is equal to 0. So I'm doing f of 0 is equal to -1, 0 minus 4 plus 3 is 1/4 plus 3, which is 12 over 4. Which is 13 over 4. Okay, so in this case, you basically will get 3, 1 over 4. So that's like 3.25. So that's going to be like somewhere slightly higher than this. So this is like 0 and 13 over 4. That's my y-intercept. And using this, you can kind of create your sketch. So if you're creating your sketch, you can use the confines of the vertical and the horizontal asymptote. You can create some test points to make a more refined sketch, right? So we can see that as the graph extends, as it gets closer and closer to the horizontal asymptote, x can approach negative infinity, and you can also create the other sketch here. So you can see that it gets closer and closer to these asymptotes, but it'll never touch, right? Because the points don't exist. Right, so you can kind of see that there. So once again, this is a sketch, guys. You can create you can create a refined sketch if you wanted to do test points, but that's not the purpose of what we're doing here. And what we want to do now is we want to look at some end behaviors just to understand what these asymptotes mean. So if we're taking a look at some end behaviors, I'm just going to do it here, EB for end behaviors. Right, I'm going to take a look when x approaches negative infinity. So as I'm going this way on the graph, you can see that as x is continuous in the negative direction, y actually gets closer and closer to this horizontal asymptote. You can see that it gets narrower and narrower, and y is going to actually approach 3, but from above. Right? Now, in the other case, as x approaches the vertical asymptote, right, and the vertical asymptote being 4 from the left side, you can see that y actually gets closer and closer. You can see that the graph is going to go closer and closer to infinity. It will extend all the way to infinity. Okay, and as x approaches 4, this is 4 from the left side, but if it approaches the vertical asymptote from the right side, 4 positive, right, y can actually approach, you can see that it's extending, y actually approaches negative infinity, and as x approaches positive infinity, right, so as x approaches positive infinity, y actually approaches the horizontal asymptote 3 from below. Okay, so this is the end behavior of this reciprocal function. So that's how you sketch out the function and list some of its key characteristics.